Yes, your screen is visible. The recording has started, so you can go ahead. Thank you.
Thank you. First of all, thank you for the invitation. It's very humbling. Uh, Let me start with introducing myself. I am Alper Sonmez from Samsun, Turkey. I'm a drummer and a sound engineer from Turkey. My history with Amiga begins from 1994. Then, of course, as many of us, I had to part with it for a while. But then I got interested in again about uh, 10 years, a decade ago. I really enjoy developing for the Amiga OS in my spare times. It's a hobby, but I give all my spare time to learning how to program, how to make Amiga programs. Uh, I also am the creator of a language Amiga OS C package for Atom.io. If anyone here used it before, before the developers abandoned the project, there were about 4,000 people around the world using it. Uh, it's uh, it's an IDE project for the Atom.io, uh, where it knows all the API functions, all the symbols from the Amiga OS API, and uh, helps not making typos and mistakes when coding for Amiga OS. Yes. This is the link to that package if anyone gets interested. I don't know anyone still uses Atom, but I still use it from time to time, especially when coding Sevgi Engine. And what is Sevgi Engine? It's just another game engine for the Amiga computer. Sevgi means love in Turkish, and it is also the first name of my beloved wife. Sevgi Engine is my most ambitious project so far. Uh, no, just I aim it to have it provide a quick way to bootstrap uh, when creating a high-performing 2D Amiga game. Games like Turrican, Lionheart, maybe Fire and Ice, where there's lots of colors, copper gradients, and smooth scrolling background. These are difficult to achieve programming for the Amiga hardware. But I also aim to enable the coder to code in C language plainly, just C language, and not even touching just a line of assembly. So uh, I think it's in the middle ground between engines like the great Red Pill and Scorpion engine, and developing a game using just assembly. And the other policies in my mind developing the Sevgi engine, which I think makes it stronger from other engines, is to be completely system friendly first. Many games made on other engines, I see they do not either run on some systems, and if they run, they don't quit cleanly back to Amiga OS. Sometimes they crash the system. Sometimes they don't even quit. There's no option to quit. Sevgi Engine's system takeover and release back routines are being tested on various hardware, OS, and ROM versions for a clean quit. I want every game to be exited back to Amiga OS cleanly. So the game you made will not require a VHD load version, and you will be able to run it directly from your workbench and quit back to workbench. allowing development in C language, which is the language I like the most. And it was encouraged by the Amiga documents back then as the main language to focus. Be efficient. Although it's written in purely C, all the performance demanding functions hit directly to hardware. They are micro-optimized at every corner, and I tried to make them as efficient as possible. All the memory allocations are done to benefit from the fast RAM if there's some on the hardware. The engine's level screen, the gameplay area, is built around the great scrolling trick by Georg Steger from 1991. It can be found on Aminet still. So you can tell it has the most efficient scroll routines ever made. Be glitch free. I see on the games developed recently on other game engines, I see some graphical glitches. Sometimes when scrolling, sometimes when switching between different screens of the game. I work hard to prevent any such glitches happening during gameplay. Use popular Amiga file formats for assets. Sevgi engine uses plain ILBM pictures for graphic elements, so they can be created on Deluxe Paint or my favorite, Personal Paint. It uses Pro Tracker for module music and IFF sound samples for sound effects. And oops. Do not limit the developer. Before I started to code for Sevgi engine, I was trying stuff with Amos, trying to create games, but Amos limits you in various ways. It only allocates planar bitmaps, does not interleave the bitmaps, and it prevents you from mangling with the copper list. But on Sevgi engine, you can do whatever you like. If the developer aims high performance games which have multi-layered parallax scrolling, sprite multiplexing, the design of the engine should not prevent the developer from achieving those. So Sevgi engine can be viewed as a boilerplate code for a simple game engine, but still allows for further development for complex features. And to support this idea, it has to be open source, so the developer can put its performance requiring routines into the code where they will be most efficient. So all the code will be open for the developer, and it will always be open sourced. I don't plan to close any part of the modules. Target platform. What hardware does Sevgi engine support? The current state of the engine supports both ECS, OCS, and AGA Amigas, but since it is written in C and it uses some functions from the newer Kickstart ROMs, I think the most suitable usage will be to use it for AGA games. And some expansion would be nice. Yes. Especially fast RAM would be very beneficial because all the allocations benefits from the availability of fast RAM. Yes. And development environment. The aim is to enable the entire development process to be done on the Amiga workbench. I've also developed an editor called Sevgi Editor as a side project, which I'll demonstrate in a couple of minutes, to handle conversion of assets and creating required boilerplate code for the screens and stuff. Sevgi engine, I'm developing it using MUI, but I'm using the 3.8 version of it, and it doesn't require any third-party MCCs, so a native IDE, yes. As I said, the aim is to be able to develop all on the workbench environment. You will need a good IDE to code, because this engine requires coding knowledge, especially in C. I'm using Cubic IDE. I prefer this. It has very nice features. But there's the great Codecraft, which is being developed recently. One can use that, of course. And if one is brave enough, you can use EditPad for your code. A C compiler, of course, because all code base is in C. The current state of the code supports compiling with SASC. Also, Amiga GCC is supported too. I plan to add more compilers to this support list. Deluxe Paint or Personal Paint will be enough to create graphics. Of course, you can download sprite sheets from the web. They will probably be in PNG, and if you have Personal Paint, you can convert them into IFF files and use it in Sevgi engine. Audio Master could be used for sound effects, or you can use Audacity to convert WAV files into IFF's Amiga format and use them as sound effects, and ProTracker for music. And the main problem with Sevgi engine is it's at this stage does not have a tile editor. At least it does not have a tile editor that you can work on Amiga workbench. I saw some tile editors from 90s on Aminet, but none of them seems to be system compatible with current Kickstart versions. But there's hope. It utilizes the popular tiled from mapeditor.org. Of course, you have to make your maps and objects on Linux or Windows, then convert your map to the Sevgi engine compatible format using the editor. And to wrap it all, the features implemented so far are: I'm supporting ECS and AGA features. I'm providing a system takeover, which is clean. The game engine implements a single buffered 8-way scrolling native level screen, which is locked at 50 FPS always. I've implemented a sprite engine, which can use the AGA supported fetch modes. The fetch mode 2 and 4 are covered. And a hardware sprite now can be reused on lower raster lines. A beam chasing Bob update engine. We have to beam chase because the level screen is single buffered. There's no double buffering. So to blit anything onto the game bitmap, you have to chase, you have to know where the beam is, and engine does it for you. Some kind of management for game object, which is the most part that I'm proud of in this engine. It has scrollable multiple copper gradients. By that I mean, if you remember the game Lionheart, there is the background copper gradients on the background play field, and there is also some colors are also being gradient on the foreground tile map. You can do that on Sevgi engine without any work. Quick access to keyboard, mice, and joystick ports. I'm not using the API functions to access keyboard, mice, and joysticks. I hit directly to hardware, and so reading the states of these I/O ports is much faster. And you can also use a mice on the joystick port, or two mice plugged in, and both will be read, and all the functions helping to read those devices are already being implemented. A non-FPU color fade engine. What is this? On the old Amiga engines, Amiga games, I see they are just decrementing color values to do a fade out. On some games I saw that. In Sevgi engine, all the color hues are protected during fade out, which means which helps a lot if the game is very colorful, and of course it's an AGA display, for example, a colorful AGA display. Fading out it's slow, benefits from this engine, and it does not use any FPU calculation. It's all integer addition and subtraction. Management of loading level assets. This is another part I'm proud of. You just list the assets to be loaded per level, and just load a function like load level does all the allocating and loading from disk of all the assets, and then you can use them in your loops, your functions, to make graphical and audio work during gameplay. Multicolor game fonts. Again, I don't use the font functions from the API to write text onto the screens. Of course, you can use them also because you're coding in C. They're available, and they will work because all the screens implemented on Sevgi engines will have valid Rust ports. Multicolor game fonts will help you have very fast rendering text with multiple colors available. I used Frank Will's PT player for audio and module playback. It's the only part of Sevgi engine written in assembly, but it's not written by me. I preferred it to speed things up, and I saw it's very efficient, very fast. I just wrote some wrapper C functions to access the PT player's assembly routines only. And finally, a GUI editor, sevgi editor I call it. It's another project I do. I try developing the engine, and I also try to develop an editor to create assets and game levels easier. And I'm planning to demonstrate it, the editor, right now, if it's okay.
Yes, of course.
Yes, I'm switching to my, just a sec. Yes, now my WinUAE screen should be on display. This is Sevgi Editor's main window. From here, let's click this first button from the toolbar. This helps create the code for a Sevgi engine game. You just name your game, let's say my game, then hit create. And then this button, game settings, will help you tweak some of the defines that will be used when building the game engine easily. For example, if you want your game to be an AGA game, you click this and it activates different fetch modes for bit plane and sprites. Raising the bit plane fetch mode is not smart because it occupies the DMA time for the sprites, so you will not be able to use some sprites on your game. So leaving it at 1 is the smart way. And if you're you are on an AGA machine, you can use sprite fetch mode and have a 64 pixel wide sprites on your game. And various settings here. Maximum bobs. Okay. This means the maximum number of blitter objects on the level display simultaneously visible. If you raise it too far, I tried it with 16 and putting 16 blitter objects on the screen. I had no glitches on a real Amiga. It was catching up. The beam chasers never lost track. And I think that's enough for an Amiga game, I think. Max sprites, again, this can be, it writes 8 here, but it's not the hardware sprite number. It's the number of sprite mediums that will be used during levels. And you can raise this up to, let's say you will display 16 sprites on a level display. Of course, only 8 4-color sprites can be displayed side by side. But if they are on different raster lines, one is on the top of the screen and 8 is on the top of the screen and 8 is on the bottom of the screen, engine reuses the hardware sprites when they are not colliding. If they are colliding, they are on the same raster line, they won't be displayed. You wouldn't like this, but you can use that for transparent or on the top or bottom dashboard to display lives and maybe the collected coins, etc. And this num game objects is the number of spawnable game objects. This is a difficult topic. Let's not get into that. And by game objects, I mean entities. Entities and Bob sprites are different. An entity can be just an invisible square that triggers something. And you have to give a number two spawnable of them, because sometimes you need a bullet, a fired bullet. It will be spawned, then despawned to be efficient. You cannot have them all calculated in the loop, because the game engine constantly updates those game objects during its loop. And I'll show it, show the code that does it in a moment. This is the level editor part of the save editor. You can choose the fonts to be loaded when the game loads. You can use the game, you choose the game fonts that you have created, loaded here. You can add more. Let's add another one. Let's remove one, like that. And levels. Here you can see level 0 is assigned to main menu, and then level 1 and more levels, like you can add here main levels and name them, etc. We'll have the other indices. Okay, this part is boring. Let's see what this does. This is a palette editor that I've coded. What it does, let me show you. Okay, this. Let's go to Personal Paint for a while. Let's load some assets from the template game which was made. Okay, where is it? It's here. Oh, I got so many files. Let's see. For example, what were we talking about? Palette. Okay. Okay, this is the tile map for my test template game, and this is the palette I used for that. So the engine should also know these color values to display this tile map. So what you do, you import that. Where is it? Assets. Yeah, here. You import it and you get the palette. You can import any IFF file and take its palette values here, edit them, save them, and it'll turn them into, let's see, let's open the output. Oh, okay, let's save it. Save it as, okay. It creates a header file. And then you use these palettes in your games. And this is a recent addition to the editor. This creates the boilerplate code required to display a new screen for your game. For example, you want to have a high score table screen with copper effects and stuff. You can create it here, giving a name, for example, high. Okay, high. Oops. High score. And you want it interleaved, you want it wireless. Let's say you want it interlaced. Clicking these changes the code generated drastically, because the copper list changes crazily. Coding it by hand would be difficult, so I created this helper window. And you have to choose a palette for your screen. Let's choose this one. And it's four color palette. You click create, and it creates the C and H files to include into your game code. This is this part. And the left side of the toolbar, we see the asset creators. For example, the first one is the game font creator. You can select a, let's find, yes, this. You can select a strip file, which you can edit in, again, Deluxe Paint or Personal Paint. This is just an IFF file. And as you can see, this is not fixed width font. This every font has different width. It's an proportional font. So you enter here the starting letter. It starts with this, and the ending character, which is this, and then you have to give the widths of every character. So it's hard to determine from here, looking at here. Maybe it's better you load it into your Personal Paint. Where is it? Here. Yes. You can then count the pixels. For example, this is 1, 2, 3 pixels. So you should say this character's width is 3. Then get to the next one and count 1, 2, 3, 4, 5, 6, etc. You create your proportional font, and it will be renderable on your game code. Let's exit this one too. This is the tileset creator. Again, you choose the tileset. You create it in your Deluxe Paint or Personal Paint. Then write its properties here and creates you the tileset file that will be loadable by the engine. This is a simple window because we don't have a tile map editor yet. As I said, you can just import a JavaScript, a JSON file. This is created in Tiled. You can import it, and when you click create, and you'll want some output directory, I think. It will export all the layers, map layers, and object layers into separate files. You can see them here. This is the converted map that SaveGengine can load. This is all the game objects loaded, and I'd like to show you some demonstration of creating those on Tiled here. Let's load Tiled. Where is it? Okay. Let's switch to Tiled window. Okay. Oops. I shouldn't have shown that. Here it is. You can make square game objects, point game objects, and assign these values and hit save. Then, just a second. Where is it? Okay. Then load into your game. And what else? This is used. This window is used to create your Bob images that your game objects will use. This is used for sprite objects. They are different because the sprite engine and Bob engine works differently. Sprite engine does not use any bleeding. It creates and holds the data as mentioned in Amiga reference manual, raw in RAM. You just point this sprite should be displayed in here. and it does not use any blitter time to display sprites. But Bob engine is a beam chasing engine. So it uses a completely different memory alignment for those images. And finally, this is the image editor. Image editor is the final step. When you created your sprite and Bob images, you can add, let's load one, for example, mouse pointers. Okay. Here you can add, you can change the offset of them, for example. Where is the hotspot? This coordinates shows the hotspot of the image, and hotspot are per image. It changes with the image set. And you can also add hitboxes. Let's say you're going to make a beat 'em up with it, and you want some other parts to be checked for collisions. You can do it here, and you can add as many hitboxes per image too. And let's try seeing this in code. When you create the project from here, okay, let's see it again. Oops, here. Okay, when you create a new game from here, it creates this code. These are the source files. It's all open. What you have to do to create a game here is to write your functions for animations. Here are some animations. This one handles, let's see, the characters move and idling animations. And this waterfall animation, for example, I wrote, does a simple three frame animation for the waterfall. You'll see in a moment. And the other thing is the collisions. When two game object collides, these functions will be called automatically by the engine. You just write these per your game objects. These functions just take a game object pointer and do everything as you wish, as you write here. And to have the control, of course, the control of the game, you have to write the display loop, what happens at every frame. And this is an example display loop. This is also generated with the template, but you can manipulate it as you wish and put your events here. And let's build and run. Now Sassi is compiling this code, and let's run it. You will be introduced a splash screen, then a menu, some click noises, and when you hit start, it loads. Now you're seeing the walk and idling animations that function had on the main player. The player is a sprite, and you see the waterfall animations here. They are blitter objects, bobs. You cannot walk off the bridge because, let me show it. On tiled, we had these rectangle objects preventing, and they, you can see, have collide function 1. And if you go back to Where is it? If we go back to this quit, it quits cleanly. We entered the game, quit back to the operating system, and everything still works. And this first function here on this list, where is it? Oh, the window is so small. Okay. Block object collision. This function here, this function implemented here, prevents the player going out of the bridge. And what else to show?
I suggest we don't go to all the details, all the detailed functions, Alper, because we are running really out of time.
Okay.
I think you gave already a really good detailed demo, and it's really impressive. It's much more advanced than I thought initially. Many
Well,
thanks for that. Is just, let's say, I don't want just, of course, just to stop like that, but is there any like specific other things that you wanted to show, or is it into the details? Because if you go into details, maybe not needed. But
okay, yes, let's not dive into details. I just want to show you another map I created for this demonstration. Up there. Let's see that too. This is an AGA screen with some other music. It has assets from a well-known game from the Amiga. The objects you see on the screen, the rotating player is a sprite, and the aliens are bob objects, glitter objects. As you can see, no glitches anywhere, and the center two aliens are dead bob objects. They are still dead. They are still glitter objects, but they're only glittered onto the screen when they get into the wheel. The other three are updated every frame, every 50 frames per second, and I'm testing this. I'm doing my test on this code because it's an AGA screen with, I think, depth 6 with 64 colors, and it handles it. A plain Amiga 1200 can play it smoothly. And that's all I have to demonstrate here.
Okay, many thanks. That's really impressive. At the beginning, when you mentioned this Revgi editor, I thought it was like coding editor, but he showed SASC and stuff like. But now I understood. Of course, it's this really the game palette editor. It's really advanced. But of course, then it's 2D oriented. Do you plan to do any 3D engine following up or to integrate that?
I've tried creating a 3D engine before, some years before this, and it did not go very well. It's a different animal, but Sevgi engine maybe one day can have some 3D elements if I can keep developing in the space. Maybe in 2 or 3 years we can have something like that, or maybe we not.
Okay, but you said it's open source and you have it available somewhere, so maybe someone can jump in and start working on the 3D part. Or...
Yes, that's my hope.
Okay.
If people get interested in, I'll be very happy.
Yeah, I think it will leverage. It will bring interest. It's really nice and pretty much advanced, I would say, when I see all the detailed functionalities that are already implemented in there. So it's not just work in progress. You could start using it already today and build a game. So many thanks. I don't know if there are any questions from the attendees. If not now, you can always post them in the chat. So I would say many thanks, Alper.
I thank you.
I will stop the recording now.